Hi guys, welcome to my channel. Today let's solve yet another Leet code question. Like, share, subscribe if you found this video helpful. Let's deep dive into the description. That we were given a circular array that we consider the first element and last element to be adjacent. Okay, fine. And we need also a swap is defined such that we could swap any two distant positions in the array. Return the minimum number of swaps required to group all ones present in array together at any location. Great. So let's go into the first example. We were given num 0, 1, 0, 1, 1, 0, 0. So here, what would be a swap is we could swap this 1 with 0. That would become 1, 1, 1, 0, 0. And we finally end up with our answer. So our answer is 3. This is our first way to do that. In a second way, we could either swap this 1 with this 0 because swap is defined as taking two distant positions and that positions could be of anything, right? So it would be again 0, 0, and 0 followed by triple ones and 0. This is the second way. In either of these ways, will get an answer 1. So the first question's answer would be 1. Let's deep dive into some other example as well. So if we consider this example 1, 1, 0, 0, 1. So for if it's a non-circular array or if it's a linear array, then the number of swaps here would be equal to 1 because this one should be coming here. And that would make the problem fairly simple because in that case we need to count the windows which is having the maximum number of ones, and simply we'll return the total number of ones count minus maximum number of ones present in the window. How would that work is fairly simple. So if it's a linear array, first let me give you an approach of how we'll be proceeding for that. And for circular array, we'll just extend the linear array approach. For linear array, suppose if we were given an array, suppose 1 0 0 0 1 0 1 1 0 1. Okay, fine. This is the array given to us. So here we need to group all the ones together. So the window finally, or the segment, that total number of ones that will be containing at the very end would be how many? 1, 2, 3, 4, 5. So at the final, all 5 ones should be grouped together, right? So what I'll do is first, instead of doing this, if it's a linear array, I'll check. So first 5 elements I'll check, and I'll check the number of ones present. Similar way, second 5 elements I'll check the number of ones present. Third 5 elements I'll check to find the number of ones. Fourth 5 elements to check the number of ones. Fifth 5 elements to check the number of ones. Sixth 5 elements to check the number of ones. Seventh to check the number of ones. Why I'm doing that, I'll tell you in a similar way. So I'll call it as the first window. Window is a group of elements that are adjacent. So the first window is having 1 1. Second window is having 1 1. Right, first window here would be 1 followed by 4 zeros. Second window here would be zeros followed by 1. Third window here would be, how many would be in the third window? This is the third window, so the count would be 2. Let me just copy paste this out. So here also it would be 1 only for third window. For fourth window, so fourth window will be starting at the fourth element and plus window size, which is 5. This is the fourth window. So we are having 2 ones. followed by fifth window, and this is the fifth window. We are having three ones over here, sixth window, this is our sixth window, which is again having three ones, sorry, three ones, followed by last seventh window. This being our seventh window, which is having three ones. Right. So we'll check this out if we are proceeding correct or not. 1 followed by 4 zeros, 1 0. So this is correct only. So here I counted the number of ones present in the each window. So if I need to add all the ones in my seventh window, then how many operations should be performed? Obviously two, because there are two zeros in it. So two ones will be outside of it because our window size is total number of ones. Already three of them are present over here. So we need to perform two operations over here. Same way two operations over here. So you got my approach if it's a linear array, right? So first we will count, we'll keep a window having total number of ones. So let me write intuition. If it's a linear array, count number of ones present in the linear vector uh, for all the windows with size total number of ones. We will find the window which is having maximum number of ones and subtract it with our original window size. So here see, if I consider this window to be my fruitful array vector where I'll include all the ones in this window, then in this window already two ones are present. So by swapping, we need to exchange these three zeros with three ones, and that would cost us three. But I'm already saying that this is my last window, which is already having three ones. So you just need to perform two operations to get the answer. So answer would be ideally this. So now here comes the second part of it, which is circular array. So I'm proceeding with a fairly simple approach. So see, if it's a circular array, instead of ones, I'll group in zeros. Instead of ones, I'll group all zeros. How would that help me? The approach here would be exactly equal to our above approach, but here I'll group all the zeros together. So if I group all the zeros together, suppose here in this example only, if these are all if these are all flipped, for example, this would be 0 1 1 1 followed by 0 1 0 0 1 0. For circular array, the first stage would be to count the number of ones if it would be as seen as a linear array, followed by, to achieve the circular part, what I'll do is similar to the first part only. I'll count the number of maximum number of zeros that can be grouped together with given window size. So here for zeros, the same, it would be the same, right? Earlier it were zeros and now it were ones. So if I brought all zeros together into a window, then number of operations to find, to group all zeros together would be two operations, right? And those two operations would be what? This one would be swapped with this zero, and this one would be swapped with this zero. So how will I get the answer in that case? It's exactly very simple. See, now here I'm telling that I have some ones. I grouped all the zeros together. So these are all zeros together and followed by all ones again. So see, we are doing zeros, but this is a circular array anyway. So we are getting all ones also grouped together. So for circular part, we can group all zeros together so that we can get all the ones also together, right? That's exactly same what I'm going to do. So first I'll assume that it's a linear array so that I'll group all ones together. Next, I'll having a condition circular array, so we could also have ones circularly aligned. For that, I'll group all zeros in between so that all ones will be connected via edges. Because zeros are grouped together, so there's no option for the right part of it and left part of it except to have ones. There may be no element as well, but if there is no element, then also it's fine. But if there are elements, then these will be grouped together to form all ones are grouped together, and we suffice our condition. So that's my approach. Let me start coding for it. So I'll call it minimum count, taking a number of nums or nums, and I'll call it checker. So my window size currently would be 0. For finding the window size, I'll iterate through the complete nums in the array, and my window size would be should be equal to checker. So what I'm doing here is to find the window size, or window size is the maximum number of checker numbers that are present within, sorry, not maximum number, total number of checker numbers that are present within the nums. Like here, our window size is 3. Here, our window size is 5. So to find the window size, I'm checking if my number is equal to checker. If that is the case, then my window size will be increased to 1. And I'll call max number of max count, or let me call it max count, should be equal to int min. So what this max count would be doing is, this max count will have max window size, or max size of checker numbers that are present in any window. Then I'll also have cur I'll name it so that everyone could understand it. Max window checker count. This would be really awesome, because I'm specifying that window checker count having the number of checker elements within the window, and max is max out of it. And the naming here is to make understand everyone. And cur window checker count will be having the checker number of elements present in the cur window. So it would be 0. Now I would do that for the first window size. So it would be for int I equal to 0, I is less than window size, I plus plus. And for finding the cur window checker count, I'll need to increment my window checker count if my nums of I is equals to check. Got it? And now I need to change this max window checker count to be equals to max of, I need to find the maximum number of ones. Here also we done the same, maximum window size, window which is having maximum number of ones. So this should be max of max window checker count and cur window checker. Great. Now having said that, how do we proceed for sliding array? This is fairly simple, no? First, our sliding window would be here, which is of size 4 in the, this is of size 3 only, no? First, our sliding window would be here. So we counted, if our checker element is 1, then max window checker count will be having 1 currently. And then we'll proceed further. So our window will be this. So we'll remove this element and we'll add this element. So how will we do that? And where we are starting from for the second iteration is at the first index. So here it would be for I is equals to 1, I is less than no, what should we be doing here? Sorry, we already have this with us, right? So we need to proceed with this now. So I need to start at this element saying that I'll add this element to my current window. I'll subtract this from my existing window. So it would be I equal to window size, because we are adding this element into our window. and I'll do that until my numbers are out completely. So until my I reach the end of a vector in the other way. I would be less than size followed by I plus plus. So I'm saying my curve window checker count to remove the element that's present over here because that's not in our window, and that would be I minus window size equal to check. If it's equal to check, then remove that because that's not part of my current window, and my current window count will be increased, checker count will be increased if my nums of I current I is equals to check. So this condition would be same now as well. Now I'll need to return my window size minus max window checker count. So I'm sure that you might have got the intuition. And having said that, as given our array is circular array, so first we'll need to find the min of it. Min of minimum count, grouping nums with 1, assuming it as a linear array to suffice the condition for circular as well. We'll do that for zeros as well, so that all zeros will be grouped in between and ones will be coming joining the edges. Let me submit this out. So it's working fine. Yes, it did work fine and fair enough complexity. To increase the complexity, you can specify that headers of C are not to be included in C++ so that I can do my syncing with stdio should be false because I'm not performing any C in or C out. This will fairly increase our complexity, I mean, time taken. So let's check this out. I'm sorry for the delay. I'm not sure why it's taking much delay. You could check this out. Earlier it was almost 80, but now it's coming to be 97. So I'm pretty sure you might have got this intuition. The variables are also named so that everyone could understand them. Please feel free to add anything in the comment section if you feel anything is unclear.